Hi there. So we have this system of equations, right, that we have to solve using Cramer's rule. All right. So Cramer's rule says that x is going to be the determinant of x divided by the big determinant. I'm going to explain what this means in a minute. All right. And the same thing goes for y and z. Okay. So if we look here, right, our capital D is going to be the determinant of everything on the left side. Okay, so for instance, this line here, right, we have 1x, 7y, and 0z, right? This one, right, we have 5x, 0y, and 4z. And the last one, right, this one, we have negative 1 for y, right, 0 for x, there's nothing there. We have negative 1z. Okay, so the determinant, right, if you recall, I'm going to take this element times the determinant of this, right? So that's 1 times 0 times negative 1 is 0 minus negative 4. So minus minus, that's a plus. Now I'm going to take 7, right? So I'm going to take, switch colors again. 7, but remember the sign convention, so I'm going to put a minus here. So it's going to be minus 7 times the determinant of these. Right, pretend that the 5, 0, and 4, negative 1 were right by each other. So it'd be 5 times negative 1, right? So negative 5. 0 times anything is 0. So I'm just going to leave it as negative 5. And then I'm going to take the 0, right? So the convention is, so this time it's going to be positive. I don't have to worry about the signs for this one. Times the determinant of this. Well, 0 times anything is 0, right? So really, we found our capital D, right? So 1 times 4 is 4. 7 times 5, right? We have two negative signs. That's 35. 4 plus 35, that's 39. So our determinant is not 0, the big capital D. Now notice over here, right? If D were to be 0, then we would be divided by 0, which is unallowed. So then we would have to apply another method such as substitution, elimination, and so forth. I'm going to go to another board here. All right, so what's the definition of d of x? So this column, right where the x's are, right? Think of it as x, y, and z. This column, I'm going to put 16, 12, and 5. So now I'm looking at the right-hand side of the system that was given in the original problem. Right, we have 16, 12, and 5. And everything else, the y and z columns are going to stay the same. So this is going to be 7, 0, 0, 4, -1, -1. So I just walked you through how to find determinants. So I'll let you do the work for this one. You should end up getting 288. So I'm going to apply the same method for d of y and d of z. So d of y is going to be 150. I'll make that a little neater for you. And then this turns to 16, 12, and 5. Right, 0, 4, -1. You should get 48. And d of z, 1, 7, 16, 5, 0, 12, 0, -1, and 5. And you should get -243. All right, last step, right? We have to, so x is going to be d of x over d. So d is 39. So I'm going to go to another board. So x is something over 39. We already found that something. It's just a matter of copying it. So we all have a denominator. They all have a denominator of 39. So d of x was 288. D of y was 48. And d of z was -243. All right, simplify these. So divide by 3 and 3, you get 96 over 13 for x. This simplifies to 16 over 13. And this reduces to -81 over 13. So yes, that's the method. It's just that simple. Let me know in the comments if you have any questions. Have a good one.